Okay, so now I'm getting started with my second try for an amplifier, because that one here, we've got quite a bit of hiss and it's only on a breadboard and it's all not that cool. So I decided to give it a second try. Got a couple of these TO3 heatsinks and a couple of TO3 devices which I could get cheaply. So what I'm now going to do is take a look at the devices I have and see whether some of them approximately match, and then this time I'm going to build it on a real breadboard, so solder the circuit up, use as short wires as possible and try to get the noise down that way. I'll start with only the power amp stage. This time I'll follow a circuit I found online, I'll link it in below, and yeah, let's see where this goes. Okay, so the transistors I got lying around here are a 2N4906, a KU605, and that is a, one over here is a RCA413. Let's see. So let's start with this one here and see what kind of specs the transistor has. Okay. Then I'll hook up the Tesla KU605. This transistor is a used one. I got it with these heatsinks. I have actually two more of these and a KU605B, but that one is broken, or rather it's leaky. So this one, okay, that's a NPN transistor, and in terms of matching, it has a beta of 17 and a VBE of, 512. VBE of 517 millivolts. Okay, now I'll try the last one. Okay, now that is the RCA 413. Let's see. It's an NPN with a beta of 23 and 542 millivolts VBE. I think the design I have is rather forgiving in terms of different betas. But yeah, basically this will be alright, because this is the only NPN power transistor that I have at the moment. So I'm definitely forced to use this one, and that means for the NPN type I'm going to use this one as it is somewhat closer and it's not used and old and crusty. I mean, these are some old Russian transistors, I think. Tesla, not sure though. But I guess I'm gonna use that one then. Unless I happen to find another one. Maybe I can one day find a matching transistor for this one, but not now at least. Okay, some progress on the project. We look at schematic. What I've built so far is let me just put it down. These two transistors, the drivers for our actual power transistors. So I haven't mounted power transistors on board because, as I said, these are big TO3 packages, and they're gonna go on their own heatsink on a separate, well, not necessarily on a separate board, but just remotely. Certainly not on this breadboard. I'll just wire them up then. So then I've also got basically this row here, this complete row, and the rest is still missing. Gonna build it tomorrow. So far it looks good. Everything works out. I haven't tested anything yet. It's kind of hard doing this with these analog projects, but yeah, double checked everything. Made a few mistakes in the progress, but yeah, hopefully they're all sorted out now. And yeah. Okay, ready for the first power up basically. I haven't got anything connected up to it. I just want to see where it bursts into flames or anything like that. So just gonna monitor the wattage going into it, and yeah, let's go. Okay, drew about 5 watts. Nothing exploded so far. anything get warm. That's fine. Okay, so now I'm gonna hook up scope and everything else and see whether we get any reasonable stuff out of it. Okay, we have power on the rails, I just checked. 73 volts total. Okay, good. So now it's time to hook up a source and see what happens. Okay, I've now got a 1 kilohertz sine wave running into it, and let's see what happens. Okay, that didn't look very promising. Let's see. Yeah, it doesn't really change like at all. Okay, we see something on the input, so it's at least hooked up. We only see short spikes on by turning it on and off. Okay, more investigation. Seriously, come on. Do you see these two leads here? They should be soldered together. Damn it. Okay, now try number 2 with the second current source working. So there's still the potential for explosions. Let's go. Okay, power consumption goes up to 60 watts. Oops. Dang it, that's bad. But I have an idea of what is causing it, so let's see. Just need to turn the scope a bit. Okay, yep, there's some heavy oscillation going on. I suspected that to happen. Shit. Give me a sec. Okay, now we're only drawing 6 watts again, so either I killed some power supply, some grounding, or it works now. Let's see. I didn't see anything evil on the scope. So I'm now going to put a signal back into it, and I'll show you scope as well. Okay. Okay, we can see some severe distortion, I think. Yeah, we were able to see some weird distortion in there. But basically, okay, that took time until the power supply drowned out. Let me see again. Essentially, it's doing things, but there's some really weird HF-like distortion in there. I can't quite make that out. So, let me actually see. Yeah, there's some evil spikes. Ah, evil spikes. I have a rough idea where they're coming from, or how to remove them. Just another second, but I'm going to show you close up. Now just to show you the spikes up close. You can see them? Yep. See them? Interesting thing is they they suddenly disappear as soon as the power supply voltage drops below a certain threshold. I don't know. Actually see, just see. Doesn't look too bad, apart from these spikes. Let's see what I can do about this. The bounciness in the waveform is, by the way, my MP3 player doing that. That's not the amplifier. Okay, before trying anything fancy, I just added a 1K load because the output was basically open until now. And now with the 1K load, oh, nothing. Wait a second, I should. Okay, wait, bad things are happening. I saw some smoke. It's as if we're missing a voltage rail or something stupid like that. It was working before, and now suddenly it just slams against the positive voltage rail. Okay, I found the issue. As you remember, it worked in the beginning and then suddenly it didn't, so I suspected some component blew or some First of all, I searched for probably about half an hour for any intermittent problem, like just dodgy contact somewhere. Didn't turn out to be the case. Actually, the problem is this transistor here, TR4. That one, I don't know why, but it certainly blew, because if I put it in, I desoldered it. First of all, I went through my circuit with a simple multimeter in diode test mode and checked the junctions of the of all the transistors until I finally found one which didn't measure the normal 0.6, 0.7 volts, but 1.9 or something. Then yeah, I figured I'd just desolder it, and here we go. If we put it into the transistor tester, yeah, sure, completely open collector. I have no idea what blew it, because if we take a look at the circuit, there's not really a lot of current even allowed to flow through that part. So I have no idea how that happened. Anyway, it's gonna replace it and then we'll see. My mistake, actually it's not tier 4 which blew up, but it's tier 12 here. Okay, transistor replaced. Let's give it another try. Let's see what happens. Okay, it doesn't jump against the supply rail anymore, it's a good thing. Okay, and again. Huh. Okay, cool, that helped. What I simply did was add a 10 ohm resistor in series with a capacitor. Now that should be spike free, more or less. I'll show it to you after it's triggered. As soon as that is jumping around, that's a problem with my MP3 player. Okay, it's now drawing 5 watts. Interestingly, okay, there's a little bit of crossover actually. I mean, we should be able to correct this. I'm just kind of scared of touching the circuit right now. There we go. Zoom in on the signal and take a look at the idle signal. Wow, that is actually a very, very small noise floor, considering that I'm not using any power supply filtering, or I don't even have bypass caps on the board. Ridiculous. Okay, 10 millivolts. Just to show you this, there's still signal present if we want. You see, wow. I mean, no, it appears pretty noisy, but considering that we have 10 millivolts per division, that's pretty good. And that jump just now, I have no idea what that is. It might have something to do with the power being a bit unstable in general. I don't know, that doesn't really make sense, I guess. But yeah, let's see if we zoom out. We'll get pretty clean soon. Shall we try to see how high we can go without clipping? I mean, we don't have any load, so this is no respect. You can't really take this as a power output test, but basically just to see when we crash into clipping on a thing. Okay, you saw that something's wrong here with all this jumpiness and stuff, but that's the maximum output level of my MP3 player now, and we're at 7 volts. Made some progress. Basically, if it works, it's about finished now. I added input terminals for power and audio. I added a little speaker like module. Here you put in your speakers. It's got the filtering for these annoying spikes on it and everything like that. And yeah, if it works, I'm happy. Well, if not, then yeah, more troubleshooting, I guess. But anyways, let's get started now and test what happens if we power this thing up. Okay, I was lucky that I did some more basic checks before I turned it on, because I noticed that, oops, output is shorted to ground. Okay, probably just a bridge somewhere. I have everything hooked up properly now, fixed the issue that I had before. It was just a not properly cut trace on the board. And with some luck it won't blow up in my face and I won't do anything else. That would be evil. Let's see. Currently no input running it, scope is monitoring the output, no load. Okay, good. Let's see. Six watts. No evil waveform on the scope, so let's see. Let me repower the thing. There we go. Sine wave on the output. That is with no load, of course, but up to that's our current maximum amplitude. Okay, now pause and zoom and then see the noise floor. So we can see it's about 10 millivolts noise floor. Okay, and the DC offset is also pretty darn good on that thing. It's minus 4 millivolts about. Okay, let's go step by step. I hooked up a simple 8 ohm dummy load to it instead of directly speakers. Now the dummy load is hooked up. As you can see, we can go up. As I said, the power supply is currently a bit underdimensioned for this circuit. Let's go up a bit. Let's see. Okay, now with 8 ohms attached, I'm currently outputting 8.5 volts, so 8.5 volts squared over into 8 ohms. This equals out to 9 watts, and we can go higher than that. Oh, by the way, at these 8 ohms and these 10 watts output power, we're drawing 37 watts from the line. Now we're at 13 volts. And you saw something. Okay, that was my MP3 player crashing. Okay, going up, going up. Clipping. Okay, here we go into clipping. That's my meter shutting down. Do you see? 15.5 volts. 15.5 volts squared over 8 means we're currently having an output power of 30 watts. Hot. Yeah, my dummy loads are burning hot. But you see, the amp has no problems driving it, and we're drawing 62 watts from the line. We're doing this, but the amp sustains it. No worries. Okay, so I guess it's time to hook up some speakers and listen through it. Okay, so let's power it on. I haven't hooked the speakers up yet. It's this cable which is flying around here. Got some music playing. And I'll hook it up. Okay, no boom or anything. Hit play. Ah, it works. Excuse the sound quality, it's only recording through my cheap camera mic at the moment. Okay, everything's about finished now, apart from the case, if I'm ever gonna build one, and maybe I'll add a preamp here onto the board, because as I said, I cannot drive the amp. I can probably not drive the amp into clipping if I'm using my proper power supply, but actually, I mean, what I'm currently getting out of it is 30 watts. That's more than I anticipated, so that's perfectly fine, I guess. Yeah, now for some just simple demos.
Take off to the skies, shut out all of your doubts, and forget what you've been told, 'cause this is what it'll take to be a Wonderbolt.
Oh yeah, and watch how long it plays after I unplug the power.
The answer, my friend, is blowing in the wind. The answer is blowing in the wind. Oh, the answer.
I guess you can call it capacitor reserve.